Hello. All right, good day everybody and welcome to class. So for today's class, I don't have really anything major planned. I just quickly want to go over the assignments that are coming up this week. And then I'm just going to do a bit of programming. So basically, if we look under assignments, Dropbox, you'll notice we have the personal project plan and we have the LinkedIn profile. So the project plan is due May 27th, so Wednesday, and the LinkedIn profile is the 29th, so Friday. So please look over the instructions for each of these, and those I'll just show you guys where they can be found. So for the project, you're going to go to the personal project plan here. Make sure you have all of the requirements met when you submit. And then the other part, in terms of the LinkedIn profile, this comes from the last lecture we did for personal branding. And basically the activity says create a LinkedIn profile, and I want you to submit the link to your profile to the Dropbox. And when you create the profile, I want you to go through and add some classmates, an instructor, follow an expert, follow the College of the North Atlantic. So basically go through and do those things. Now, the last class, I walked through a website here that talks about your personal branding, okay? And we went through a bunch of things that you can do in terms of your resume, in terms of networking. There's some really excellent tips on that link. Now, I also have a link posted for creating a LinkedIn profile, so please go through and read that. Follow that when you do your profile that's due on Friday. I was thinking I might go through that article, but a lot of the stuff is very similar to what I went through on Friday with creating your personal brand. So I'm going to leave that to you guys to read through those steps and apply that to your LinkedIn profile. All right. So let's get to what I'm actually going to do in this video today. So basically, one of the things, we talked about, obviously, creating your profile, your personal brand, but the other one is your coding, and specifically the GitHub. And one of the things I want to emphasize is, one of the really cool things about setting up a GitHub is that you're not necessarily going to just program something and then finish it and then just be done with it, okay? The idea is that you can create something, start working on it, get it to a certain point, and then you can always pick it up and continue working on it whenever you feel like it or whenever you have some extra time, or it can become kind of an ongoing hobby for you. And this comes down to the advantage of having a portfolio and using version control, that it really sets you up to program every day and to really push and improve your skills. So the Connect 4 is a great example for this. We've created the Connect 4 board, but there's certainly more work we could do. You could probably make a really large list of different enhancements or improvements that you could make to the Connect 4. So for example, you could add better art assets. You could add better animations. You could add a main menu that allows you to pick which player you are. You're going to play the yellow or the red pieces. There's unlimited, basically, that you could add. You could, for example, a more advanced feature, you could add network play. So I could basically publish this to the web, and you could set it up so two players could remotely connect and play against each other. Now that's way beyond what we're doing right now, but that's something you could research and add. And wouldn't that be a fun and interesting feature to add? Now, what I've decided, I'm going to demonstrate adding a new feature today. And the feature that I'm going to add is artificial intelligence. Okay, or at least we're going to call it that. It's going to be a very, very simple version of AI, but it will allow us to play against the computer, to basically have an opponent making moves in response to your moves. And this is a pretty neat, for me anyway, this is something that I enjoy. I'm interested in games and how to program simple AI for them. And having a Connect 4 game that, just allows you to play two players to me isn't all that exciting. I like to see when the computer makes a move. So let's get started with that. Okay, so I'm going to go to okay, so I've got my Connect 4 here, and I'm going to open up it in brackets, and let's just preview what where we left off. Okay, so we have the board here, and basically we have it so we can click and we can place pieces, and then if the one of the players wins, we get a win message, and then we have the option to continue playing, okay? So basically what we're gonna do today, I'm gonna add the feature so that when I click and I add a piece, then immediately after, the computer is then going to go and make a piece. Now, another thing to keep in mind too is we do have a few bugs. What I just noticed is when I started that last game, it was a red piece that fell. But if I refresh, it's a yellow piece that starts. So obviously that's a simple bug where depending upon how you finish the game, it doesn't reset the player who starts the next game. Okay, so everything seems to be working there, and I've got my code available here. So basically there's a few simple changes that I need to make to get this to work. So the first one is I'm going to go to my functions, and it's probably a good idea just to quickly review all the different functions I have. So just starting up at the top of my JavaScript, we can see that I have an enumeration, which are the different game states. So we have playing, we have the 3 terminal states where the game has ended, and then we also have another state, dropping piece. And this is a state where we're still playing the game, but we've selected to place a piece, and that piece is now animating. So we don't want to be accepting any input while that's happening. And as you can see, we start out in the playing state. We load in a bunch of assets here. Then we have our positions on the board. So we're using, so we have start pause equals array 4. So 0 horizontal position, 1 vertical pixel position. Okay, so start pause and end pause, these are variables that are used for our animation. So they're basically an array where we pack some data that we use to place the piece, and then we interpolate and we move the piece to its final position. We also have a timer object that we're going to use to time basically having the piece drop. These player offsets, those are related to a pixel offset to placing the assets, the piece on the board so it looks correct. And then here's where we actually have our board. So we're representing our board using a 2D array where we have 7 columns and 6 rows, and we initialize this to the value 0 to indicate an empty board. Okay, so these are all of our global variables. And then we come into here and we have a function to get the mouse position. So this is what's going to be called when we click the mouse on our board, and basically we get the X and Y positions on our canvas. And then if the game state is playing, we try to place a piece in that column wherever it was clicked. If we're not playing when we click, then we're going to check to see if we've clicked a button. Okay, we're basically checking our position to see if we clicked inside a certain rectangle, and if we do, we reset the board. Now to fix that bug, I need to set player equal 1. That's going to reset it back to the yellow player. So that's our mouse position. Now from here, we notice we have a place piece function that's called when we want to place the piece. So that's this function right here. And basically what it's going to do is it's going to loop through all of the rows in that column. It's going to start at the bottom and it's going to start moving up. And as soon as it finds an empty position, it's going to set that as the position it wants to drop the piece to. And as soon as it does that, it then moves into the dropping piece state. And it's going to set up a timer to call the drop piece function. And that's going to be called every 33 milliseconds or 30 frames a second. And then we come into the drop piece function, and basically this is going to move the piece down as it's being placed. And that's done by calling start pause 1 plus 30. And it also calls this draw function, which will draw that piece. In addition, it checks to see if we've finished animating, and if it does, it's going to stop the timer by calling clear interval right here. Then it finishes by placing the piece in its final position, and then it calls this check win function. After it's done that, it then sets the player to the next player who would be making a turn. So the next function we should look at probably is the check win function. So check win is going to loop through, and it's going to look for 4 conditions to see who's won the game, whether it's a column win, a row win, or one of the 2 diagonal wins. It's going to loop through and check those. And if the win condition occurs, it's going to then set the game state to either yellow wins or red wins. It's also going to check to see if the game was a draw, that the board is full and no one has won. If none of those conditions happen, it's going to set the game state to playing to allow the game to continue. Okay, so we've got that. Now we also have mentioned the draw function, and this is going to loop through and basically draw the assets on the board. It does have some special code as well that if we're in the dropping piece state, that it is going to have some extra code that's going to draw that position as it's dropping. And that's it. So the nice thing here is we don't have a lot of code. At some point, we really should refactor this code. In other words, I should take this, place it in a separate JavaScript file. And because I'm also planning to add AI, it would probably be a good idea to create a separate file that contains just the AI code. That way, my JavaScript files are not going to become very large and unmaintainable. But for now, I'm just going to continue with this workflow. We can always go and clean up that part of the code later on. So let's start with, there's basically 4 changes I need to make here, and I'll just walk through each one. So the first one is in get mouse position, which is the function called when we first click our board. I'm going to have it so that I only want to place a piece if we're in the playing state and the player equals 1, okay? So only if it's the yellow piece player is going. And so yellow is going to be the human, red is going to be the computer. So now when I run this, I initially placed that yellow piece, but now when I click, it won't let me place the other piece. And this is because we want the computer to now handle placing the piece for red. Okay, so we've done that. And so that's pretty simple. Now, the next thing that happens is we call place piece. And we also have, so we go into place piece. And this is going to call a function which is going to be a drop piece. That's going to then animate the piece falling into the column that the player clicked. And so let's look at drop piece. Now drop piece, it calls this function check win. And check win right now, it sets the game state. So the game state here, game state equals playing, game state equals yellow wins or red wins. That's being set inside that function. One change that I would like to make is I'm going to modify check win. So instead of setting the state, I'm going to have it return the state. And that's a really simple change to make, but it's going to be needed because the AI component that I'm going to write, it's going to want to call check win without actually changing the game state. So in other words, the AI is going to want to try a move. It's going to want to call check win and see, did that move win the game? Did it lose the game? Or does it just have no effect? and then it's going to want to keep going. But right now, because check win changes the game state, that's not a good thing for the AI, okay? So I'm going to modify check win so that instead of setting the game state, it's going to return the game state. So basically it comes in here and it loops through all of the different positions that it's looking for a win state. So if the count is greater than 4, we know the game has been won. So instead of setting game state equals yellow wins or red wins, I'm going to say return. So now I'm returning the value of yellow wins or red wins. And I don't need, well, I'll keep this console log. I just need to put that in front of the return. And obviously I don't need the break state anymore. And I also don't need to worry about setting the state to playing because the state is already, should already be in the, well, I'm not going to return right here, so I can just leave it, okay? So if the check win function came in and it looped through all 4 of the win conditions and it found one, it's going to return immediately, okay? If it didn't find one though, the for loop is going to exit and now it's going to come to this part here. So basically I don't need to do this check for if state equals playing, so I'm going to remove that. And really all we're going to do is we're either going to return a draw or we're going to return that we're playing. So it's going to loop through and see if the entire board is full. If it is, it's going to set, instead of setting the game state to draw, it's going to return state.draw. Else, it's going to return state.playing. Okay, so there I go. So now that the check win function is not actually setting the state, I need to now go and make a small change here in where I call check win. Now I'm just going to quickly do a search for check win, and you can see that it's only called in 2 places. These 2 are commented out, so it's only called in one place. So what I need to do now is I can just say let I can just say game state equals check win, okay? And that's pretty much all I need to do there. So what I should probably do at this point is just go and test my code to make sure I haven't completely broken everything. So I'll hit F12, I can look at my console, I'm not getting any errors. Okay, and so I can't get very far because I have that change, the previous change here. So I'm just gonna comment this change out. And now we can place these pieces. And let's just do a condition where I end up winning. So I'll do a diagonal one. There we go. Okay, so I could keep testing it, but it looks like everything's working. I'm not getting any console errors. It resets. Everything seems to be pretty good. All right. Okay, so we've made a few changes. And let me just undo that change right there. So we do want to only allow the yellow player to make human moves. So now I'm going to add my AI function. And basically, the AI function that I'm going to use is going to have the computer now make a move, essentially. So I'm going to add a new function, and I'm going to call this so I'll call it function, and I will call it computer turn. And the way that I want this function to work is there's going to be 3 things I'm going to check, all right? The first one is going to be I'm going to look for a move which wins the game for the computer, okay? So in other words, if the computer can place a piece on the board that wins, that makes a match, then that's what the computer would want to do in that case. Now, if they don't have a winning move, the other thing I want to look for is look for a move where the human can win the game. Now, obviously, if it's the computer's turn, the human can't go make a move yet. But what we're looking for here is there a position on the board where the human in their next move is going to have the chance to win? If there is, the computer is going to want to block that position. Now, if neither of those conditions are true, then we want to make a random move, okay? So in other words, we randomly pick one of the columns and we make a move in that column. Now, with this algorithm, with this described, so this is going to be our algorithm. One thing I should mention is this is not the best AI, okay? This is not going to play the game at a high level. It'll definitely be beatable by a human player, which is kind of a good thing in a way. It's not going to be much fun if the computer never makes mistakes and is unbeatable. However, this is a good starting point, and we can always come back and improve the AI. And one thing you guys might want to think about is, well, given these three conditions, is there other improvements or other changes you can make to this algorithm to make the Connect 4 play better, okay? So that's something you guys can think about. I'm gonna now move on and start basically filling in this algorithm. Now, we could start with looking for a move which wins the game, or looking for a move where the computer wins the game. But the best one to look at to start with is making a random move, because that way we can at least get the computer making moves and we can verify that we don't have any major bugs in our logic and in our game loop. So basically, when we want the computer to make a random move, we need to loop through every column and loop through every row. And when we find one, sorry, not every row, we want to loop through every column. And when we find a column that has a position empty, we can then make that as the move that we're going to use. So basically, I need to do a for loop, and I'm going to do a nested for loop. Just trying to see if there's an example of one. Okay, so here's a nested for loop here, so I'm just going to copy that. This loops through the entire board to check, see if we have a draw. So I'm looping through every row and looping through every column, but in my case, I want to loop through the columns first. Okay, so I loop through every column. Actually, there's another example here of a for loop I want to use, I think. Okay, maybe not. All right. Okay, so I'm going to start at column 0. I'm going to move all the way over to the 6th column. And I then want to check okay, I'm gonna start at the bottom, so I'm gonna use this inner for loop. So I'm gonna check at the bottom position. So in other words, I'm gonna start with the bottom row, row 5, and I'm gonna move up until I find an empty position, and that's going to be the position that I will then place my piece at. So in other words, if the column and row are 0, then this is where I want to place my piece. So I'll leave a little comment, place piece. And to do that, I basically go board column row equals, now we know the code, the way it's set up, player 1 is yellow, player 2 is going to be red. So I want to say that board column row equals 2. And then I can go ahead and I'm now going to actually place the piece there. So to do that, I'm going to call the function that the human player calls, which is just place piece. And I'm going to place it in the column. So actually, I don't need to actually place it using that code because it's going to happen inside this function. So I say place piece, and I pass in the column. Okay, and that is pretty much what I need to do. I then also need to break out of this loop. So I need to then, I could probably go and just return, okay? That's gonna basically exit the function. The other option to break out of the loop would be, I could say column equals 7 and then break. So break is gonna break me out of the inner loop, and then when I set column equal to 7, when it comes back to the outer loop, it's going to exit out of that as well. Okay, so we can, I think we can pretty much try this out. I just need to then make a call to this function. And the place to do that is going to be in the drop piece. So when I drop the piece, when it ends, it's going to check for a win. And it's going to also check to see, it's going to switch the player. So I basically need something here where I say if game state equals state.playing and player equals 2, then I'm going to say computer turn. Okay, so let's try this out. Okay, so we've got it making moves. It beat me. That's kind of embarrassing. But one thing you'll notice is that it's always going to make the same, it's always picking the first column. And so what we've missed is adding the randomization. So essentially what I need to do is in my computer turn, what you can see, this outer for loop always starts at column 0, and then it increments by 1. So it's always going to fill the board from left to right, which isn't very exciting. So I'm going to show you a quick trick right now so that we can fill the board randomly. We can pick a random column. So instead of saying let column equal 0, column less than 7, I'm gonna use a counter variable I. All right. And this is maybe you would consider this a slightly, you might not have seen this trick before, but it's still a fairly simple one. So I have my counter I. And now I'm going to say let column equal, and I'm basically going to take I need to get a random amount. So I'm going to say I'm going to go let random column offset equal math.random times, and we have 7 columns. So this is going to give me a value. Math.random will give me a value between 0 and 1, but 1 is exclusive. So it goes all the way up to 0.99999. It doesn't include 1. So when I multiply by 7, that's going to result in a value between 0 and 6, which is what I want. So I'm going to do a parseInt on that. Okay. And I've got my random column offset. So now I'm going to say let call equal I plus random column offset. Now the only problem by doing this is the column is going to potentially go outside of the array. For example, if my random column offset is say 3, okay? When I loop through this array, the first one it'll be 0 plus 3, so 3. Then 1 plus 3, 4, 5, 6, but when I hit 7, that's going outside of my array. So the issue there is I need to then do, I need to take the division remainder of the division operation for the size of the number of columns. So in other words, I need to say column equals column mod 7. So that's going to return now, that's going to take the column value, and it's going to return a value between 0 and 6. So now this is going to basically be randomized. So the column value will actually be random. So I can go in here, and now let's try this out. Whoa. Okay, so that's not good. Okay, so what did I do wrong? Okay. Okay, dare not look at that. Not getting any console issues. Oh, I see. Okay. It's because it's my trick here to set the column value equal to 7. I need to set it now to I equals 7. Now this is a bit of a hack. There's probably a better way to do it. Probably the correct way to just be return. That's probably a little bit nicer. So that's going to basically end the for loops. Okay, so let's try this now. Okay, so now it's making random moves, but it doesn't play very well. It has no idea. I can easily defeat it. Okay. So the good thing is we have the game loop is running. Now, the next part, though, is we now need to fill these out. We need to look for a move which wins the game, and just as importantly, look for a move where the human can win the game. So we want to block the human from winning. So it doesn't really matter which one we do first. Probably, let's do the one where we block the human from winning. So basically, we're going to do the same sort of, the code's going to be pretty similar. So I'll copy and paste this, and I'm going to look for, so I'm going to take the column and the row, and I don't need any randomization for this in this case. Okay. Okay, so what we want to do is we look through all the columns starting on the left, okay? For each of those columns, we find the first free available position in the row, if there is one. Then what we're going to do is we're going to place a piece. So we're going to say board, column, row equals, and we're going to say 1. So in other words, we're saying, what if the human player was able to place a yellow piece in this position? If they do they win the game? So we place the piece there. Now we're going to call check win, but we need to have a variable. So I'm going to say game state after move equals check win, and we have column row, and we are checking the win for player 1. So if game state after move equals state dot yellow wins, so if the human player won the game with that move, then of course, what we want to do is we want to go ahead and we want to place the piece there. We want to block that win. And we also are going to want to return out of that. Okay. Now the other thing, though, we have to be careful of, we placed the piece on the board, but in many cases, well, in any case, we don't want to keep that permanently there, okay? We only want to place pieces over the board using the place piece function. We don't want to call board column row and set it to a piece. We only do that to basically check a win condition. So after we set it, we need to unmake that move. So this is basically the process of we make a move, we test to see if the player won, but we need to remember to unmake that move. Otherwise, our board state is going to get corrupted. So I'm going to say board column row equals 0. And at this point, then we do our check to see if the human player could win the game. If it is, we place the piece there. Okay. Now, regardless, we want to break. We don't want to continue checking the rows. We want to then move to the next column to continue checking to see if there is a position where the human player could win. So let's try this out. So the idea is so right now this will be a good test. I'm going to place a piece here, and the computer player should go ahead and place a piece right there, okay? And it does, it blocks me. Now, of course, it's not that smart. In this case, there's 2 positions there, and it's not able to block both of them. So I could potentially go here for the win, but I won't. And let's see, the next place it should go will be right in that position, okay? So let's try that, and it does, right? Now, the only other thing to keep in mind is the computer player now is not smart enough to see if it's going to win. So right now, actually there's no win yet. Okay, so now it does have a winning position, and it doesn't take it, right? It doesn't see that, hey, I could win the game. So that's going to be the last thing that we're going to add. So now I'm going to fill in the code for making a move that wins the game. So this is going to be very, very similar to the code I just added. And in this case, I'm going to, instead of placing a yellow piece, I'm going to place a red piece, okay? And the check win function, the 3 parameters it takes the column and the row of the last piece placed, and it also takes the player that you want to check the win for. And I want to check the win for the computer player now. So I change that to 2. And if the game state is red wins, then I want to make that move and I want to return, and that's it. So now we can try this out. Come in, I place my pieces. And at this point, red will have a move to win the game here, right? We can see on that diagonal, and it'll take that. It'll take the win, okay? And I'll just do one more quick test. It blocks. Okay. Now, if I don't block the piece there, it is now going to take the win. Okay. All right, so that pretty much wraps that up. It was a pretty simple change, but one thing that I probably need to do at this point is to go in and place my JavaScript in a separate file. It really shouldn't be included with the HTML at this point. And then I probably want to put my AI code into a separate file as well. Basically, the idea that we want to have separate modules for different functionality makes the code easier to work on, certainly. And I guess the other point I want to make too is this comes back to the idea of programming every day. The whole idea of having a GitHub, having some projects, personal projects you're working on, is that you can take the time every day to go and make a small improvement or maybe research some information. With with Connect 4, there is an actual proper way to create artificial intelligence that is much, much stronger than what I've shown you right here. And so I'll leave that as an exercise to you for now to go and look up, okay, if you wanted to create an AI that would defeat what I've done here, how would you go about doing that? And there is an algorithm that chess programs use, checkers programs use, that you can apply to Connect 4 that will pretty much result in perfect play. In other words, your AI will be unbeatable. So it's not the most fun AI to play against, but it is kind of an interesting thing to do. So maybe in a future video, I will go and add on some more. So anyway, I'm going to wrap this up. Please work on getting the assignments for this week done. You should also begin starting on your personal project. Okay, you don't need to wait to hear back from me. Everyone who's mentioned anything about their personal project, it sounds good to me. So you can certainly begin working on that. Make sure though you submit the plan before you begin actually working on it. So I can take a quick look. And then of course later on this week, I'm going to be doing a more comprehensive video about resumes. And also I'm going to probably include some information about cover letters with those. Okay, well that's it. Have a great rest of your day. Bye.